welcome to our virtual bootcamp around IoT. My name is Darren Hogan. I'm the Product Manager for IoT at ANS. Alongside me is Mark Johnson, who's the Head of IoT.
Good morning.
And today, hopefully, we're going to give you a taste of the Internet of Things from an ANS perspective, some of the things that we've discovered on the landscape. We're going to hopefully take you through a technical demonstration of how you can take data, ingest that into the Azure IoT framework, and then visualize that data as well using Microsoft Power BI. And we'll take you through that technical demonstration shortly. We do have an agenda. We've got a packed show for you today, so an overview of ANS and IoT, the approach that we take within the IoT sphere. Then we'll look at the demonstration, some case studies that we've been working on recently with some of our customers, some interesting conversations that we're having there, a concept around digital twins, which is the Azure platform, and the concepts of taking a physical space and then representing that in the digital world, and the advantages of doing that within the Azure framework. And then if there are any questions at the end, then we'll be happy to take those. I think there's a Q&A button on the side of the WebEx panel that you can use to ask any questions that you might have during the presentation, and we'll be happy to take those at the end. So, without further ado.
Yeah, so what I'm going to do, I'm going to take you over a quick overview of ANS, where we've come from. The people that don't know us, I think there's a few people I can see in the panel that do know us. So basically, fundamentals, cloud service provider, formed in 1996, 300 staff, predominantly based in the northwest. We have got a satellite office down in sunny London. And as you can see, we have a few of the typical enterprise credentials for ISO, PCI, and cybersecurities. We are in the, I think, number 27 in the top 100 Sunday Times list, so pretty proud of that particular award. And we also have our own academy where we grow our own technical talent around the cloud. We're quite committed to push. Okay, that's done. Solutions that we tend to have, we certainly deliver, so managed cloud services and digital services now. We have an app dev team, IoT, which is what we're discussing today, big data connectivity, and we have the usual vendor certifications and partnerships through Microsoft, Cisco, AWS, and Gartner. And from a connectivity perspective, over 20+ network carriers that we're partnered with for our own WAN infrastructure. We have qualified engagement. We certainly look to partner, and we're not a supplier, so we're not anybody that deals with tin anymore. We like to partner with our customers, and we have a strong vertical focus. We're 50-50, 50% public sector, 50% commercial. Our solution quality, the way that our ratios from a technical review board and CRB is probably 2 to 1 from a pre-sales consultant to sales, and we make sure that the particular criteria are hit. So we always make sure there's a technical review, and once that's been done, our sales and commercial teams will commercially review to make sure the deal is the best deal we have for our customers. Also, we're now running boot camps, so the Azure Bootcamp, which is a 2-day boot camp with our Officer CTO, very, very popular. Struggle to get everybody on that, but it's a very good engagement. And we also like to engage with our customers from a C-level networking perspective. So skills, over 200+, so we're very technically focused as a business, and we have all the skills required to deliver on our CSP. And recently, what we've gathered from a certification perspective is Azure MSP Expert. Only 9 partners, Microsoft partners in the UK have got that accreditation, 40 worldwide, so we're quite proud of that particular one. So we've ensured that we've got all the necessary skills to deliver on what we need to do from an IoT, big data or cloud perspective. Also, we have a strong PMO, and we have now transitioned, obviously, a recent acquisition of a company called Webantech. From an app dev perspective, we're now transitioning to doing Prince to Agile, and very much our engagement is from an app dev perspective, from an advanced services perspective as well. So obviously managed services, over £60 million contracted, so we're a safe business to work with, safe pair of hands, quite useful. And obviously we have all the right cultures and developments within managed services to be able to deliver that for our customers. As you can see, we've got DevOps culture, we've got continuous aligned. We have Glass, which is our service management portal, which is in-house developed, and it's built around our customers. And we're introducing new things such as ChatOps, and which is around making sure we have a new age culture to engage with our operational teams. And then moving on to some of the customers that we are working with in the public sector. Obviously, we're working with Guys and St Thomas, Salford City Council. Some of the names that you probably recognise, mixed between HE, NHS, and local government. So moving into the approach that we've taken. So we've been working on this now for probably around about 12 months now. So it's been a bit of a hard slog, but we've learned a great deal over that period of time. So some of the statements that we're getting from the industry that, the Internet of Things isn't a technology revolution, it's actually a business revolution, so it's enabled by technology. So everything really that we start with is started with business outcomes. So we're not talking about a platform that we start with, we're talking about how we're trying to change things from a business perspective, and it normally starts there. And the thing with that dev and within a digital service or IoT is certainly if you're engaging with customers now, you're engaging with a lot of different peoples, different entities, and different lines of business within the customer entity to sort out what solutions need to be driven from a business outcome. And that's how we've kind of engaged with a lot of customers, which are in the use cases that we've done over the past 12 months. And it's been a bit of an eye-opener when you're dealing with people that don't really have an idea about what technology can deliver. So it's been quite useful. So generally, just going through some of the real-world IoT things, and you can see some quite obscure things around what things are being connected. So dogs from the little chips that we can put in the dogs now. So not only can we locate them, we can also find out if there's any particular immunity issues that they may have for the dog. But loads of things you'd expect that we want some connectivity. So we're also trying to drive the extraction of data from a lot of these solutions, which is probably the new goal in technology speak. But what I'm going to highlight now is that IoT sits in a lot of places, as you can see on this slide here. But I'm going to pick on one which is pretty obscure, but there's certainly a use case out there that is actually a Microsoft use case, and it's actually around cows, so a connected cow. So these guys, 3 farmers from Germany, had a few problems with trying to ensure that they could to grow the cattle that they have within the farm, but the actual sanitation process was actually extremely difficult for them. Only 3, they're quite a large herd. So some of the things to identify when you're doing this is that when a cow's on heat, you need to spend 20 to 30 minutes a day in the stables and up to 4 or 5 times a day, which is obviously very time consuming for 3 farmers trying to get the right time to find out if a cow's on heat. So looking at that, some of the things that you need to take into consideration, some of the period of ostriches is round about 12 to 18 hours. You've only got 21 days period. Normally occurs between 10 o'clock and 8 o'clock in the morning, or 10 o'clock at night, 8 o'clock in the morning, and it's normally done visually by the farmers. So they have to be there to be able to look at the signs of when a cow's like to be on heat. So some of the inception rate there of 70%, relatively high, but it's still that could be improved on, and the pregnancy rate is relatively low with regards to this. So what they've looked at is how can technology help with this? So yes, you're probably laughing at now. This looks like something that somebody done on ASBO, but it's actually a pedometer to show a cow-based Fitbit, for one of the better words. So they attach these to measure the steps, and they identified that the steps were the best way understanding when a cow is likely to go on heat, because the number of steps increases quite significantly. So they could then start to measure that and use some of the features that sit in the cloud to measure the patterns of cattle over a period of time, which introduces to this particular chart here. So the start of the process, you can see at the top there in the first line, and then the optimal part of that is that 18 or 16 hours later is the optimal part for artificial insemination. But one of the interesting facts that they found, which was probably they didn't expect to find this during this, which was just finding the optimal time for artificial insemination, is that before the line on the left-hand side, so 4-hour periods before that, they could actually ensure that that particular insemination was creating a female cow. After that line was a male. So they could actually choose the type of cows that they wanted, but also if they wanted a bull, they could also look at the artificial insemination. This is all collected from the data that they've got from this. So you can see quite important now, not only the business outcome was to be more efficient in the way that they delivered this process, was also is gathering the data, how they needed to collect the data, and how they needed to visualize that data and the actions they could take after that. So you can see this is the setup. So Fujitsu was the system that you, with Azure, set this up. So you've got obviously a dipole antenna which basically connects that pedometer back into the router, which then had a connection back into cellular connections into Azure, where that data was ingested. And you'll probably see the lab setup will show you some of the components that set up in Azure to be able to ingest that data and do something with it. Okay, so the industry itself. So we know, if you look, anybody knows anything about Gartner, Gartner is obviously a leading market analyst. We know that basically that this is becoming, over the last probably 2 years, it's becoming mainstream with regard to people looking at adopting IoT. I think we've got a lot of people in public sector, so smart city, smart building, smart campus, smart parking, all these different initiatives are coming up, and we're seeing more and more tenders now coming out from lots in Newcastle. Solved doing a lot of great stuff there as well. So we now start to see some real, some positive action within the market leading to this, and obviously Gartner produced a lot of papers on how we should approach this from a customer perspective and also from a partner perspective. So we're using a lot of the information from Gartner to be able to extract that. So obviously there's some strategic roadmap stuff. So identifying what your current state looks like, what future state should look like, and be able to adopt some of these technologies. So looking at a platform that can support multiple initiatives. So that is normally a common data platform. And then looking at how you would integrate multiple different sources from different entities within it's a city, whether it's going to be an NHS. So if you're looking at how you also not looking at when you're looking at building maintenance, or you're looking at medical asset tracking, or the temperature on where the medication is kept, things like that. They're all different kinds of initiatives, but they need to be aggregated into one place so you can start to use things such as machine learning and cognitive services and things like that, all the good stuff that sits in the cloud. And they've also produced a reference model, which people are starting to use and taking this over. So that tiered model there. So we can really go into more detail as we speak to customers in the future. But you can see now it's a serious, it's now got serious traction within the industry now. So it's good to see. So, as I said before, we always start with business outcomes, and they could be anything around operational efficiency, which is a common one. That's still one of the ones. Reducing operating costs is probably the #1 reason that people start to look at IoT. But also looking at efficiency. How can we make this more efficient? It might be waste management. We want to empty bins when it needs to be more optimal, or we need to find from a patient care perspective, I need to look at medical assets. Not only can I locate the medical assets, but also can I also understand when the maintenance schedules are likely to go, and can I start to optimize them and reduce costs? But at the end of the day, we are improving patient care, so we're getting people through a lot quicker because we're locating some of the most, I would say, the important equipment is available to nurses and clinicians as and when they need to do it. So there's loads of use cases that we can do, but it normally starts with that. Productivity is another one, so Workforce productivity or optimization is another one where we start to look at how we would drive all this productivity, these efficiencies. So it normally starts with business outcome. Then we start to look at the architecture, and then we start to look at what things have already been deployed, what things need to be deployed, so we can gather the data. So as this is a high-level thing, it's defining what that is. We have things that collect data, so the sensors, actuators, MEMS, all that type of stuff that sits there. We also have the data that is important. So when we've looked at the business outcome, what data is the most important stuff for us? How can we get that data out from existing systems, or we may deploy some standalone infrastructure to be able to collect that data. Once we've got the data, we then ingest that data into the cloud or a common data platform, and that allows us then to generate insights and get some analytics. Maybe we use some possible machine learning algorithms, or we can start to look at some historical trends, but we'll also look at real-time alerting and things like that. We can gather that from insights and start to build up a good picture aligned to that business outcome. And once we've got an understanding or a visualization of what that looks like, we can then start to build the actions and then get that feedback loop pushed back into the infrastructure to make the changes necessary dynamically rather than waiting on and being reactive and doing this. So this is kind of where that sits. Although high level, you can probably see there's a lot of moving parts within that. So broken down, so as I said, we approach this from an app dev perspective. We found this is the best way that we can draw things down. We get a lot of user stories. We speak to a lot of different people, a lot of different lines of business, and looking at what their perspective is. So their perspective is likely to be different from IT. OTs like to have a different perspective from IT, and then you've got line of business where you might have research, or you might have an estates department looking at different things, the things that they want to look at are completely different to the way IT may look at this. So we collect user stories. We use some of the modern tooling around capturing them stories, and then we can mark them stories accordingly to see what is going to be a priority, what's going to create the most impact. So once we've done that, then we look at the things. So we actually look at what things have been deployed. So we've got an embedded system. So we've got BMS. We've got all that building management. Have we got some standalone system that is collecting other data? And we need to look at how we would actually get that data out. Then if the solution is looked at bespoke deployment, so we may look at room occupancy, might look at space utilization, you might look at wellness. They're the type of things that you may have to deploy some bespoke standalone services that still have integration points that we can drag data such as temperature, humidity, CO2, VOC, all them type of things that you might want to collect to get that information back in and get that and extract that data and find a way then actually backhauling that back into the cloud. So connectivity. So connectivity is split into two. So you've got connectivity for the sensor perspective. So you've got loads of new kind of protocols out there now. 6LoWPAN, which is like a low power solution. Your Bluetooth, obviously not new, but we now start looking at infrastructures. Cisco's infrastructure now supports multiple radios, and we'll start to support Bluetooth in the future. We've heard some information around them actually putting Sigfox radios in access points. So you're going to have a wireless network not only just doing 802.11ac, but it will be doing things such as possibly LoRaWAN, Sigfox. So the infrastructure from a wireless perspective will be able to handle multiple different things that will connect back into the infrastructure. So once you've got that connectivity from the sensor to a gateway, then the gateway backhaul data is normally over a WAN. Again, you need to make sure that you can encrypt traffic or you can route traffic accordingly. So obviously we have our own WAN. We can show that in the schematic very shortly. But backhauling the traffic needs to make sure, for one, it is secure, so it's encrypted, and ensure that it's delivered to the appropriate place within the cloud. So again, this is another one. If it needs to be protected, if the data that we're collecting is part of a service that is critical, obviously looking at the way that the connectivity is done, so high availability, resiliency, all that type of stuff, from a WAN perspective or even from an internet perspective is obviously pivotal in making sure that service is integral. So once we've done that, we look at the data. So we start to look at ingesting the data. We use the components that Darren will go through when we look at the lab. Is basically we ingest the data through IOT Hub. We then, once we've got that data in, is where do we route that data? So we will probably want to store the data, so we can use that data for machine learning. We may want to use stream analytics to Also do real-time alerting. So we want certain conditions happen. We want to alert certain people. We'll set that stuff up in the cloud as well. Also, databases will feed whatever visualization we want to do, whether that's going to be an app. So we go, if you look at the analytics now, we've got some BI, we've got logic apps, we've got some AI and some cognitive services that can use the data that has been stored and stored in the right format. So the transformation's taken place. We can then put it in the format that can be ingested by apps, can be done by used for machine learning, it can be used for cognitive services, so visual, knowledge, all that type of stuff that sits within the AI framework. So this is what our architecture looks like. So on the left-hand side, you can probably see bottom left, if anybody understands IoT, it's a massive ecosystem play. It's taken us 12 months to establish the right partnerships that we need to work with. We provide probably 80% of this end-to-end model is done by ANS. The other 20% is done by solutions aggregators or large distribution entities. So we work with Arrow and Tech Data, so they're global solution aggregators in the IoT field. So if you look at for Arrow, for instance, we partner with them, but they have 3 divisions. They have an enterprise compute services division, so looking at software, enterprise software that you may want to deploy. So they will be able to look at that type of software deployment. They have an advanced integrated systems that's looking at the right gateway that's likely to connect sensors back. And then you also have a components division. So the components division is they will have relationships with industry recognized manufacturers, your Schneiders, your Bosches, your Philips, where they can provide some of the embedded system requirements, but they can also build a sensor specific to your requirements. So if any entity said, actually, I wanted to do, and we've actually done this with a maintenance provider, UK, and in fact they're actually European. They want to build their own one for measured lifts. So we built a specific, something like 8 sensors in an enclosure, so they can be fitted to a lift shaft and be able to measure the components on a lift. So it just shows you the capability in that area to be able to go out and build your own or have an industry recognised one is being done by these guys. That's where they specialise. We don't specialise in that area, and we don't see that as being a value add for ANS per se, but certainly in that business and getting the data out, that's why we partner with these guys. Also, we have our own WAN, and there's all the providers, or the main providers that we work with. So ensuring that we can provide that connectivity, whether that needs to be separate to your existing connectivity. We're also a mobile virtual network operator, so we partner with a company called Wireless Logic, but we also have a direct partnership with Vodafone. So be able to provide connectivity either to the sensor direct, so using NB-IoT, or we take it from the gateway. We can back all that data over that network. Everything is encrypted from the gateway or from the sensor, so that medium can still be the internet. But if we require, or if there's a compliance or regulation requirement to deliver that over over a connectivity mechanism, then we can put a private WAN in there to support this, or we can run over the existing WAN and still encrypt and keep that traffic separated. So we also have dedicated express routes into Azure. And we have direct connection to AWS, so we can provide them connections from our own WAN. So if you need to spin these services up pretty quickly, then we've got these services on net, so we can pretty much take advantage of them, that particular connectivity mechanism to Azure and into AWS. So as you can see there, the main functions, which Darren will go into a bit more detail, but all the functions that sit within a common data platform, and the importance of that is being able to integrate multiple different sources. And we say that is, okay, we've got the sensors on the right-hand side, but on the left-hand side of the schematic, they could be embedded. So you've got to think about how we get the data out from an embedded system. You've got sensor as a service, which is a new factor. We're seeing that people providing these services and adding some other attributes to that service to provide a recurring service. So we're finding that you would take an API call from these guys and be able to ingest them into the common data platform, or you'll take an external feed, such as the weather or transportation systems, or even some smart metering systems. You'll be able to ingest that data into the same common data platform, multiple different data sources, probably in different formats that will need normalizing. So all the hard work that needs to do that happens in the ingestion and within the cloud. and you can just see that, that main piece there, all that normalization of data. Once the data is being obviously normalized and then it's at rest, and it's then available for the consumption of, if it's it could be a portal, it could be Power BI or business intelligence portals, it could be an application. So we make sure that data is in the right format to be ingested by whatever end system it's likely to be. So you can see we've got the end-to-end pretty much there, and obviously security from an end-to-end perspective is done from the sensor all the way through to the application, and it's all tiered. So from physical through to the connectivity into the application and storage, all that is encrypted and secure. So there is new services from Microsoft where they're now starting to do Azure Sphere, which is a solution that will provide security down to the MCU. So the microcontroller will have embedded hardware security and will connect back into an Azure security service, which will be Sphere. So as you can see, this landscape is changing quite significantly, and people are taking this kind of seriously. So security, this is just another aspect of, how security is done, where we look at security and the different elements that are, or the different areas or different pillars that are involved in security, and ensuring that the sensor itself is secure. If it isn't secure, then we put mechanisms into place from a networking perspective, where we look at network segmentation, and we look at making sure that we can verify or even use other systems around the identity of that particular device to make sure it's secure. And obviously then we encrypt that traffic over whatever medium it's likely to be, so whether that is going to be an internet connection or it's a WAN connection, and as soon as it gets into Azure, it's secure by default. So that's just to show that some of the pieces there from an IoT security perspective. So the approach. So we've kind of built this approach over the last, the last 12 months, and everything starts from assessment. And basically, what we found is that through this assessment, we run, evangelism workshops. We do pre-discovery. There's a lot of moving parts. You can see a lot of data formats. Can we get data out? Can we not get data out? Data in. There's more often a requirement to write a business case to qualify whether that particular solution is worth doing. And that's probably how we would start. And we start from an app dev perspective. So we have a P&D process. And quite frankly, that is the only way you will get this type of solution working. It has to be. I have to start by having all the right information and ensuring we can collect all the right data to proceed with that. Then we move into the prove, which is proof of concept or pilot. Once we've done all the hard work in the assessment, prove what we found in that assessment. So we'll just make sure that the business case stacks up, the solution and the blueprint or the design or the HLD that's been produced from the assessment will work in the context that it's been assessed at, and it delivers the outputs or the outcomes that the customer requires. Once that has been proved and that it's stringent test criteria, we then move into deployment, and we will help transition that particular solution into a deployment or production environment. And on top of that, we would look to provide some form of managed service, whether that's co-managed or managed entirely by ourselves. That's where we found there's a lot of value as well for customers going forward. Because as you'll probably find in the evolution of this, you're probably hitting one initiative. You'll probably be adding the initiatives all the time, because IoT, as you can see from one of the previous slides, there's a lot of different use cases that you can see that will start to attract additional requirements to ingest this data into that common data platform and start using that data, correlating it with other data sources to get some more meaningful insight, which is what IoT generally is all about. So I talked briefly about what the engagement timeline looks like. So the evangelism workshop is normally done, by our solution architects. We sit there, we work with customers, go through user stories, we look at attracting different areas of that particular customer's environment. So we look at line of business. We may look at, somebody from finance, could be somebody from estates. Obviously, IT will be involved. Some of the OT people will be involved. And you sit there and you look at all the perspectives of how people do their work and how IoT would be able to help them. And this is where having somebody within your enterprise or your environment that sits horizontally across the business that can capture everything that's required and look at the perspectives of the different entities within that business. And this is also approved by Gartner. Gartner are saying that you need to ensure that this tier sits between the business and how you're going to deliver all operations, and that's how that should sit, and gathering all the right information, all the right perspective, because everybody in their own right would turn around and say, actually, you know what, my requirement is more important than their requirement. So that needs to be managed, and that's either going to be an IoT architect or something that is being given that particular role within your business. Once we've done all that, we then go and do a pre-discovery workshop where we go in and understand fully, with probably a lot of the people that we've sat in the evangelism session, of what data is important, and then capturing the value chains that we're likely to go and deliver. So the pre-discovery allows us to price and size the appropriate plan and design exercise, which is next. Once we do that, we produce a service and solutions architecture and also some prototyping and POC and pilot deployment options. And then we'll look into the build, and obviously we've got some data science stuff that we're likely to build over the period of time. So we'll build models, business models, and data models that will satisfy the outcome or the business outcome requirements. And obviously we'll always optimize analytical outcomes, because obviously then models will need to change significantly as we get more sources in. We start to change then models to making sure the outcomes are specific, and then we'd onboard all them services into operations. So that's what we've found is been the best approach with the engagements we've had so far. So who we work with, there's quite a few people we work with, and we're working with. In fact, there's a couple of ones that are not actually on there that we're recently working with, which I'll go into some of the use cases later. But you can see there's an appetite through quite a few, commercial as well as public sector entities there, looking to engage in IoT. And some of the finance streams actually don't come from IT, they come from outside, they come from different business entities. So we're working with a couple of NHS trusts where the fund sits outside of IT, so it's so track and trace and medical assets. So things like that, they are uncovering, but it just needs managing them entities. People are just going out and doing their own thing. And people have heard of shadow IT. There's also shadow IoT where people are just doing their own thing. So it's important to be able to evangelise and create a centre of excellence that can feed into the rest of the business. Say, listen, if you've got these opportunities or you want to explore these opportunities, come into the centre of excellence, and we'll explore this in more depth. Okay, so I'll introduce Darren. So Darren's basically put together some how this stuff all puts together and what we've done in the demo is looking at some of the components that make that up. Darren will explain that a little bit more better than I will, but he'll take you through how he's built it, why he's built it, and hopefully it should demonstrate all the parts that make this particular the solution up. There's also other moving parts, but we'll try and keep it simplistic. This is the first of probably multiple webinars we're likely to do in the future, which will expand on what we're doing here. So I'll pass you over to Darren.
Perfect, thanks Mark. So yeah, really good insights there, and hopefully you get there a sense of the scale of the challenge around IoT, all of the different components, all of the different connectivity media, and then right at the front of the show, understanding what that business use case is. It should always be the first question. It's all right collecting data, it's all right using sensors to get data and understand what's happening, but what are we going to do with that data? What's the use case? What decisions are going to be driven by that data? So taking a step back and kind of zooming in a little bit, what we thought we'd do is just to bring this to life, is to take you through a short demonstration. So this is the architecture of the demonstration. It's very small, but what we're going to do is we're going to have a virtual sensor that's going to be running on my laptop here in the office, that's going to be sending out telemetry data, so temperature and humidity across the internet, and that'll be ingested within IoT Hub. So Microsoft's IoT Hub is a very scalable, a very robust ingestion mechanism for telemetry data and for messages, so MQTT, publisher subscriber model, and it is the kind of front door for all of the messages that we want to take into the solution. We can then, from the ingestion and the command and control capabilities of IoT Hub with sensors being able to change certain aspects, we then take that data and we can then route it through the cloud platform and take certain functions on it. So we're going to ingest the data into IoT Hub. We're then going to pump that data into a function called Stream Analytics. So Stream Analytics allows us to make queries on data in real time. So if you think about it a little bit like an SQL query running on real-time streaming data, that's probably the best way of describing it. So we can do selects, we can do joins, inner and outer joins, we can take data and augment it and enrich it with reference data that's already sitting at rest within the platform. So it's a highly scalable, highly powerful function. We're going to use that to send the data from IoT Hub into a data set that's going to be consumed by Power BI. So we're going to be able to visualize the data that the virtual sensor is going to send us in real time from a couple of different aspects. Firstly, from a Power BI dashboard with a manual refresh, then from a Power BI dashboard with an automatic refresh in real time. And then finally, we'll just take a quick look at an alternative way of viewing that data, which is a web application again, which will be sitting within Azure. So if I get rid of all this rubbish, hopefully you can see my screen. So what we'll do is we will start our virtual sensor. Hopefully you can see the messages coming up on the screen there. Whirring away. So this is sitting on my laptop. It's just a piece of code written in Node. And what we're doing is we're sending data into IoT Hub. So previously I registered this sensor with IoT Hub. So this is the Azure portal that we're looking at now. I'll just take you through this. So this is the IoT Hub aspect of the Azure portal. And within the IoT devices aspect here, we can see that we have a device registered through the use of connection strings to be able to register the device within IoT Hub. So that's sitting there merrily sending data away. What we can do, because there are command and control aspects to Azure, we can actually send commands to the sensor. So we can actually tell the sensor to change the specific aspects that it's sending us. So if it's sending us temperature and humidity, we can say, look, we're just interested in humidity. Or we can say reduce or increase the amount of data that you're sending us. So if I just go into this, and we'll just set this going again. So hopefully that's going to start sending us data. It will. And with a back-end application, so what we're going to do now is we're going to send a command to the sensor to change the telemetry interval. So hopefully you can see that change there. So we've sent a message through IoT Hub to the sensor to set the telemetry interval to every 10 seconds. So previously we can see here that it was sending every 1 second. And now it's actually sending every 10 seconds. So we can actually command and control the sensors directly from IoT Hub, which is useful when we have to make changes on the fly and do various other aspects. So if I just go back and start this again. Again, we're sending telemetry data. So let's just see what IoT Hub is seeing. So we can actually see live streaming information from IoT Hub and actually see the confirmation that the messages are actually being received. So this is what IoT Hub is seeing from the sensor. So this is the telemetry received messages. So the actual values there and the connection strings associated with that device. So that's the authentication mechanism really that we use to connect sensors to IoT Hub. Cool. So that's merrily sending data. Let's go back into IoT Hub, and if we go to our dashboard, just give this a quick refresh, we should now see that data is coming through. And we can see that data here. So this is just showing the device to cloud messages coming through IoT Hub. So you can see there it hits going up towards 60 a minute or 1 a second, which is what we had. We changed the telemetry down to once every 10 seconds. We will see that go back up because I've refreshed the telemetry interval now back to once every second again. So we have data coming into IoT Hub, and that is all well and good, but obviously we want to do something with that data. So we mentioned earlier about stream analytics. So within the Azure portal, we can create a stream analytics job, and the stream analytics function takes an input, which is the input from the IoT Hub, so that stream of data, and can do a number of aspects. So we talked earlier about the queries, and this is the query that I've got set up here. Hopefully you can see that on the screen. So what we're doing within this particular query is we're selecting everything, so select star. And from the IoT Hub, so this is the input, we'll look at this in a second, into the output, which is going to be the Power BI dashboard, send everything. So just send everything into Power BI. So let's take a look at what the input looks like. So it's a stream input, and here we can just see the name of that input, which is Device Simulation IoT Hub. It's a messaging endpoint, and there are access policies to allow us to share that data, and then authentication mechanisms. A consumer group is created so that we can listen to that data. This is the default consumer group that we're using here. And then from an output perspective, as mentioned, it's going to be a Power BI dashboard. So I've pre-registered this simulation stream to Power BI, the stream analytics job. So this is going to send the data to a data set within Power BI called Device Telemetry Test. So that's where the data is going to sit. In order to start this working, we need to start the job, and we want the job to start now, so let's start that. Whilst that's starting, it'll take about 60 seconds to start. We'll click over to Power BI. So these are some data sets that I've created earlier, and this job has already run, so we've already got here, remember, Device Telemetry Test was the data set, so this is where the data is going to sit. Within Power BI. Let's just make sure that the job is still starting. So what we'll do while that's still starting is we will create a dashboard and wait for the live data to come in. So within Power BI, we can select the data set and we can create a report. So for those of you unfamiliar with Power BI is a business intelligence, business analytics tool that allows us to take data sets, whether they be static data sets or dynamically created, whether they be local Excel files, CSVs, or in our case, a stream of data generated by a sensor, and visualize that within a, within a dashboard, and allow us to interrogate that data and drill down and gain some insights. So within this workspace, we will create a dashboard and we will create a line chart to be able to visualize this data. I can see here on the right-hand side, we already have some fields pre-populated. These are the data fields coming through from the sensor. So the job's now running. Let's just give that a quick refresh just to see if the data's coming through yet. That'll start any second now. So let's choose some values to represent on this line graph. So to start with, we need an axis. So we'll choose a date time field for that. We have two here to choose from. So we've got an enqueued UTC time-coded date field, and we've got an event processed. So the enqueued time is when the job is enqueued within IoT Hub, but we're going to choose the time that the sensors actually timestamp the data to come in. So we'll take that and we'll drag and drop that onto the axis field. And then the values that we're interested in, obviously, is temperature and humidity. So let's take those values and drag and drop them in here. Because this job's been running for a while, what we'll do is we'll just filter the data to take the last 1 day. So we want the last 1 day's worth of data. Let's apply that filter. And you can probably see here right at the end, the data is just starting to come through. So let's hit refresh. Yes, it is. So we can start to look at that data in real time. So we can see the timestamps there of the data coming through. So a quick and easy way of getting data represented on a dashboard within Power BI. So which is all well and good. I guess the challenge around that is that you have to hit refresh. It isn't really real time. So what we can do is we can take a real time view of that, So if we go to workspaces, we'll get rid of that for the time being. Let's create a brand new dashboard. Let's call it device telemetry. We'll create that. So this is a brand new dashboard, and what we want to do is we want to create a new view. So let's add a tile. And on the right hand side we can see the resource pane, so we can see that at the bottom we've got an option to use real-time streaming data, which is absolutely what we want to do. So let's hit next. Our data set is here prepared, so device telemetry test is the data set that we want to use. Again, that's the data coming from the sensor in real time. The visualization, we want to use a line chart. And then from an Axis perspective, remember last time we used that date time field, so let's use the processed date time field again. And the values that we want to use are temperature and humidity. And we'll hit apply on that. And there we go. So in real time, we can actually now see the data streaming live through from the sensor. Oops, wrong window. From the sensor, and then being represented on a graph in real time in Power BI in just a few clicks. So you can already see the power of the system. Remember, IoT scales up to millions and millions of messages and thousands and hundreds of thousands of sensors. So the ability to be able to ingest that data into a single platform is really, really powerful. If we wanted to start to add other aspects, we can. Let's choose a different visualization. Device telemetry test, we want to use that again. Let's use a card this time. And we just want to look at humidity, for example, and apply that. So now we can see that the humidity value is changing in real time alongside the stream of data that we gain through. So that's kind of Power BI. We've got a couple of aspects there. We've got the static data with the refresh, and then we've got the real-time data using the dashboard. The final kind of aspect that I just wanted to touch on in terms of a visualization is the ability to be able to use a web app. So within within Azure, you can use functions and containers and various other aspects to create web applications, built-in repositories, published up to Azure and then published out to the internet. And in this case, what we're going to do is we're going to take a pre-canned web application to be able to visualize the data in real time. So if I just select the web app, this is the web app console. So currently the application is halted and stopped right now. What we'll do is we'll start that application, and within a few seconds, this is the external URL for that app. So we'll open that. It'll take a few seconds to publish, and what we'll be able to see is that we don't necessarily need a business analytics tool or a business intelligence tool to visualize data. So that app started this weird and wonderful application, but what you can see there from a web app perspective is that in real time we can see that telemetry data coming through and visualize that in real time without the need for Power BI. So hopefully that's given you a very brief whistle-stop tour of some of the powering capabilities of the cloud within IoT and within Azure IoT Hub. Going back to the, if I just get the presentation back up again. So within the architecture here, we've just concentrated on Stream Analytics, Power BI, and the web application. But Azure is it's a cluster of functions basically. It's a number of applications that we can use to be able to ingest this data. So it's not just Stream Analytics. You can do things like Event Hub to do message routing. You can use things like Logic Apps to do what Mark talked about earlier, which was that feedback loop. So it's all very well and good at analyzing data and see it in real time. But if you want to take action on that, if you're, other than having somebody sitting in front of a dashboard 24/7, 365, you need to be alerted on things like, for example, threshold breaches. So we'll talk about that in a few slides' time regarding CO2, but the ability to be able to send an email alert, for example, or a push notification to somebody when something has breached. So if we get back to our, look at our application, you know, if one of these values breaches a certain predefined threshold, then we probably want to know about it. So if we have, you know, sensors in an office building and the temperature reaches 80, 90, 100 degrees, that's clearly a sign that something's wrong. Somebody needs to know about it. Conversely, if we have, you know, light sensors measuring luminance in an office environment and sound sensors as well measuring noise, what we can have is something where, you know, one of these gets triggered out of hours. So we have a trigger to say that the lights have come on and it's 3 o'clock in the morning. Is that normal behaviour? Again, we want to make somebody aware of that. So the power with Azure is that you can wrap all of those functions up in a single platform. The platform as a service aspects of Azure are very, very powerful from that perspective. So hopefully that's given you a taste of the power of the cloud in that respect. Some use cases, Mark.
Yep. Well, it's not showing on the screen for some reason.
Okay. Bear with us a second.
No, still one there.
Some gremlins in the works in terms of presenting. We'll continue regardless, so I'll share this with Mark and hopefully it'll catch up.
Is it worth stopping sharing again?
Okay, yeah, can do.
Yeah, so the use cases, we've got probably two main ones. We've got two little ones we can also mention as well. So the first use case is around a large property builder, owner, managed office provider, and yeah, let's see, it's come up now. Yeah, so we've worked with these guys for quite a significant number of time over the last probably 6-7 months, and it's probably where we've got the majority of our information with regards to how we would like to deploy IoT. Although we've worked with kind of other different entities, but this is probably our furthest forward development. So they own, you know, 120 buildings in the north of England, very large managed office provider. They do a lot of development. But we've been working 2 parallel streams with them. So we've got a smart spaces solution we're putting in 4 of their buildings at the moment, just looking at temperature, humidity, CO2, light, noise, and they just want a good understanding of the environment in their buildings, not only for their tenants but also for their employees and visitors. So it's pretty important for them to start taking this next step into the intelligent campus kind of world where we're seeing a lot of activity. The other stream 2 is around their energy and sustainable energy. I would say their strategy, trying to drive a lot of operational savings. They've got very tough targets to hit, but they're also a managed energy provider in their own right. However, they've got probably 7 or 8 different systems that make up that particular service that they presently run that needs to be aggregated into one common data platform. So we're working on producing this common data platform which will not only support the stream 1, it will support stream 2 as well and provide all this data. So that'll be connecting all the sensor data, the billing data, integration into BMS, which seems to be a massive topic at the moment. A lot of the BMS manufacturers at the moment are discussing around it not being cloud enabled, but we know that the major providers, your Schneiders, your Bosches, Philips, Siemens, have all got cloud-based, although siloed cloud-based solutions that will deliver multiple BMS integrations for multiple buildings on one platform. So they've got some really tough targets to hit on that side. But what the common data platform also does for us is it attracts other initiatives. So they've got some parking initiatives they want to look at. We've got a little bit of a a case study on what we've done in our own parking solution at ANS. They want to look at the telemetry from the maintenance engineers out on the road. They want to bring that data in as well. Bike racks, understanding the behaviours of visitors, tenants using them type of facilities, and also be able to adjust the flow to be more optimal for their tenants and their staff. And one of the ones on the stream one was also around space utilisation. So what meeting rooms are being used, how often they're being used, when they're being used, and some of the conditions in their environments as well. So it's very important to see that it's their business that they want to do. So what we've done is we've looked at this, we've managed this end to end. So we've gone through the timeline that I showed you, and this uses some of the components that Darren's discussed, but there's a new one there called Azure Digital Twin, which is a new service provided by Azure, and we are probably the first UK partner to build on this. It's in public preview, so it's not on general availability, but we're working closely with Microsoft and iron out a few bugs, but we have got it pretty much working and looking to get that ingested into Power BI very shortly, and probably a Power App. But also what we have done is how end users start to use and consume the service. So we are building as we have an app dev function, we're building a bespoke app that will look at, concierge services, looking at, be able to book meeting rooms, be able to order facilities, coffee, tea, food, looking at the environment itself, looking at the quiet areas, looking at the areas that are well lit and things like that. So that to me is how we want the end user to consume. So this is why most of these things are started from an app dev perspective when you look at that life cycle. So from a sensor perspective, we're using a company called Yansy. So Yansy are a Swedish-based customer partner. They manufacture the sensors and the gateways. And this is specifically a sensor as a service. So they will provide all the lifecycle services for the gateway and the sensors, which means security updates, firmware updates, and then they will present an API to Azure for ANS, and we'll ingest the data, and then we'll start to produce the visualizations and the actions based on the data that's been ingested from this solution. What we're seeing in the marketplace is that a lot of electronics or sensor manufacturers are looking to add more services revenue to their portfolio and create this sensor as a service. You'll see it's quite, although very siloed, they do smart buildings, that's what they do, they don't do anything other than that. So this is why the common data platform is extremely important, because if we want to use that data in conjunction with weather data, for instance, and if you look at energy, if we're looking to heat a building and the day's warm, then we don't need to have the temperature or the HVAC working at the rate it should be when the weather could actually provide a lot of the energy that was required in that building, for instance. So that's one sensor manufacturer there that we're dealing with. And the other one's Disruptive Tech. This is like these sensors are like the size of a Scrabble piece, and they can pretty much fit anywhere. And again, very good for very discrete sensoring, and they do temperature, humidity, they do door open, closed. But again, this is where the market's going. The battery life on the majority of these sensors now, anything between 5 and 15 years. So looking at replacing batteries from an operational perspective can be quite cumbersome. However, this makes it an easier way to technically update some physical over a period of time, where actually you're likely to be more recent or more up-to-date technology using more relevant sensors that might be applicable in that particular customer's case study. So this is another that we're looking to use as well. And then digital twins. So this is what we've built. So our Office of CTO, working heavily with Microsoft, have built the Azure Digital Twins. I'm not going to go into too much detail on this because the next webinar, probably next month, will be a deep dive into digital twins, which is really a way of digitally representing something within the cloud of something that is physical. So we can control it, we can look at how we manage the metadata from them particular sensors. We can control everything in the software, which is a lot easier for us to manage and a lot easier to pull information out and build models in the cloud based on something that's physical, which is obviously very difficult to do. That's where digital twins comes into it. But this is what we've built for Bruntwood. And basically what we've done for them is we present all this. So we've got logic apps, so we've got real-time streaming. So some of the attributes that we're pulling data from, we'll send an email alert. So we've got specific email alerts to report on several conditions, and then we're also presenting some of the stats into Power BI, and then we're using Cosmos DB and a bit of SQL as well to do some machine learning and historical trending, so we can start to get some real good insights into the behaviours of particular buildings. And then once the energy environment comes on, so smart metering, so water, gas, electric, some of the telemetry data from maintenance people, some of the parking stuff will all be ingested into the same place. We can start to use digital twins as well as these services to get insights from multiple different sources and start to get some correlated patterns as we build the model from a data science perspective as well. So that's quite a new and interesting. There's not many people doing this globally, so we're quite proud to be working with Microsoft on this particular project initiative. Although crude visualizations here, the reason I wanted to do show these ones, these are the kind of data that we've pushed. Our app dev team will basically produce something that's a lot more aesthetic for this particular customer. But what I want to highlight here is the bottom right one, which is air quality, and what air quality means, and why people are talking a lot about smart spaces at the moment, intelligent campus and things like that, because it has dramatic effects on productivity. So just to show this, I'm going to move across you, Dan.
Yeah, certainly. So this is a representation or a graph of a sensor that we've got in the office here in Manchester. So we have sensors deployed all the way throughout the building, and this is picking up noise levels in a particular office. So what we can see at the beginning there at 8 o'clock, somebody clearly has walked into that particular room to have a conversation or a call, so the noise levels go up. And then there's a period of quiet between sort of 8:30 and then 10, and then the noise levels ramp up again as the office is used throughout the day. In and of itself isn't particularly interesting, but when you start to overlay things like CO2 on top of that, then it starts to paint a different picture. So we can see at 8 o'clock when the office starts to be used, and the CO2 levels within that office obviously rise up, but the dissipation levels are very, very low when that office isn't used. So the CO2 levels throughout the day don't dissipate and actually rise and rise and rise. And I think on this particular day, just looking to the left, I think we're at about 1,600 parts per million within that particular office. So this drove a logical conclusion that that particular office isn't well ventilated, and we had to take some measures to make sure that we kept those CO2 levels and parts per million down under usable levels. And the studies have shown that there is a demonstrable impact in cognitive functions as a result of high levels of CO2. So between 1,000 and 2,500 parts per million, bearing in mind we're at 1,600 on the previous graph, there's a 35% reduction in basic activity. Use of information is impacted around 60%, but then using initiative and higher cognitive functions, a massive 91% reduction in the ability of somebody to be able to perform at peak levels. So, it's not just a graph for a graph's sake, it's not just measuring something for the sake of measuring it and putting a sensor on the wall. There's actual real demonstrable benefits to being able to measure and manage these kind of things. And we had no idea that this was going on in the office until we started measuring it. So, proof positive that it's useful to be able to have this kind of information. So one of the other applications that we've been looking at, which is probably something that all of us suffer from in the workplace, which is parking. So we're no different to anybody else. We have the same problems and challenges that other organisations do. We have a number of employees that use the building on a daily basis, 250 at peak, with only 50 parking spaces, and obviously not everybody lives in Manchester, so that was a challenge for us. how do we analyse how that parking is being used, and how do we take some actions off the back of that analysis and try and provide some benefit to employees. So there are a number of parking solutions or parking space solutions out in the marketplace, and there are a number of different ways of cutting this. One solution is to use parking-based sensors, so a sensor that's physically drilled into the surface of the car park, typically electromagnetic, so that when the car rolls over the top, it sends a signal back to the platform to say that that space is occupied, and similarly when the car rolls off again, it sends another signal to say that that space is free. So highly accurate, but obviously there's a cost associated with that because we would need a sensor in every single parking space. Entrance and exit counting sensors, so bump strips, counting, or a camera, an ANPR camera, for example, counting the number of cars coming in and out, and then deriving an occupancy level as a result of taking one away from the other. But the kind of road that we took with it was that there must be a more elegant solution to this, a more computer vision based solution. So we started off on the road of using an open source computer vision model. So we used TensorFlow, which is basically a machine learning algorithm and a computer vision model that allows us to have a camera that actually sees a vision of what a car looks like. So it actually counts the cars and actually identifies them. So what we had to do is we had to train the computer vision model with around 160,000 images of what a car looks like. So it actually learns to identify a car versus a person versus a bike versus a bush, that kind of thing. So understand what a car looks like, which, in and of itself was fine. It was a piece of work that we undertook to try and derive some benefit. But actually, we then learned about the Azure Custom Vision service. So pretty much the same kind of model, but actually it took minutes rather than days to train. A vastly reduced number of images, prediction API to be able to predict the occupancy of car parking spaces, not just monitor them. And then finally, we could export that into other functions. So what we ended up with is a camera that's mounted on the rear of the car park here, or the rear of the building, sorry, at the building here in Manchester. And the camera is actually looking at the car park 24/7. So what you can see here is what the custom vision model sees. And each of these green circles represents a bay that's being monitored. The green aspect indicates that the custom vision model thinks that that space is free. And the percentage is the accuracy of that analysis, basically. So it is 100% confident that that space is empty after the mid-training. So hopefully we'll be able to step through a time-lapse video of exactly what happens when the model springs to life. So we can hopefully see here cars being parked and the model recognising that that space is now full, and then the accuracy changing as a result of that. So this is the algorithm learning in real time and actually viewing the car parking spaces become vacant, become occupied, become vacant again in real time, which has really helped out and really adds benefit. We'll come on to some of the visualization aspects in a second, but just in terms of how that kind of breaks down as a service or as an architecture, we can see here on the right hand side that we've got the potential for a number of cameras. This introduces a concept of something called IOT Edge. So if you imagine that there's a number of calculations that need to be done there to maintain that visual model, rather than having the cloud compute all those, and if you imagine that in certain scenarios you would have images of cars being sent all the way to the cloud, and that could happen multiple times per day, the requirement on bandwidth would be extensive, and it wouldn't be the most efficient use of the resource. So one of the functions within IoT Azure is IoT Edge. So we can push all of that computing to the edge. So we have a concept of an edge gateway that is crunching the numbers on the occupancy and looking at those images and understanding whether or not that space is occupied or not, and coming up with a value of, say, 0 or 1, 0 for unoccupied, 1 for occupied. And all the gateway does at that point is then just send a value to the cloud for processing rather than send the images. So there are a number of aspects to that. Stream analytics we've looked at before, and an SQL database just to store the information. And this is how we're kind of visualising that within the office here. So we can see some visualisations about what the car park looks like, some spaces that are free and empty, a number of vacant parking spaces, and bringing in things like weather. So does weather have an impact as to whether or not people drive to the office? It probably does, but it would be nice to be able to demonstrate that within some analytics. So we've included that as well. And then on the right-hand side, that's a mobile application that we've built as well to be able to demonstrate, the occupancy of the car park. So hopefully there, that kind of gives an indication of some of the power behind some of these technologies. From a machine learning perspective, once we've got the data in the cloud, we can then learn and start to predict occupancy. So looking at historical space utilization, their time of day, day of week, week of month, month of year, are there any correlations that we can then go back and train on a machine learning model to try and predict occupancy hotspots in the future? Bring into that things like people's calendars, meetings in the office, any kind of events that are happening that might constrain that resource further, and then we can start to build a really rich machine learning model that will allow us to be able to predict occupancy in the future, so that we can plan our movements and activities in line with that. So from a camera-based system there, we can see that we can really build a valuable set of machine learning information to be able to provide employees with more information about our resources. Mark?
Yes, so Salisbury NHS we've been working with, so they're looking at, probably the past 6 months, looking at a medical asset track and trace solution, and leveraging their existing wireless infrastructure, which is Cisco, and their new, I think it's DNA Spaces, which is their new CMX. So it's like an analytics platform that Cisco provide in the cloud and has APIs. So we're looking to use that and some tags that will sit on these devices, and looking at other alternatives to see when these devices have been powered on, where they are located, some wayfinding around it, so nurses and clinicians can find the equipment closer to them. And for maintenance schedules is how do we look to optimize these maintenance schedules such that I do all the devices at the same time. I can start to be really optimized from a cost perspective, as well as making sure that the equipment that has been used is going to be used is going to be tested and is being calibrated for the use of that particular job. So that was a big thing. They had a separate budget outside of IT to do that, but what drove the budget itself was the increase in productivity of staff and getting patients through that particular trust as quickly as possible. And this is what the business case was built on. The assistive tech piece was looking at how we would start looking at deploying sensors within managed properties. So they also work with their local housing association. There's some other, I think the universities are involved in building a solution that will satisfy making sure that if it's a patient that has Alzheimer's or just old age, they can predict falls. They can look at the activity and patterns of the. If Brenda gets up at 10 o'clock in the morning and she makes a brew, we understand that's what she's doing, and that information can be put back. And obviously, we're getting people out of hospitals and into their own homes in a managed, and still being able to provide some managed care. So that's what this solution was all about. The other solution, which is another solution on top of this, which was a lone worker solution that they're looking at. So they have a lot of medical record staff that have to still physically ship records to one end of the hospital to the, and out of hours they do this on their own. And some of the IT staff also work on their own as well. But some of the areas of the actual hospital are from the Second World War, so very dark, cold, security is not so much. So we are working with Arrow on producing a ID card holder that will provide a falls prediction. It will also do not only internal but external, so community visitors, radiographers going to community sites, having these particular passes for discrete alerts, visual alerts as well, and audible alerts. So that's the type of stuff that we're working on for that particular NHS. But again, all the building stuff we've been talking about, so if you look at Royal Liverpool as an example, they've got 780 rooms. We could certainly put in some of the sensors that will give, making sure that environment in each of the different rooms are at the right managed levels for that particular patient. And then if it goes outside of that, we can start to look at, either turning HVAC on or looking at air handling units to be able to cleanse the air. Things like that could start to be invoked proactively rather than doing it manually from staff when they should actually be doing other bits and bats. So that's that one. I'll do these ones quickly. These are just, Imperial College, number one issue is lifts, surprisingly enough. So this is where we work with Arrow to produce a purpose-built lift sensor that will manage the ride quality, the door opening, because apparently, according to the lift manufacturers, if there's any change in speed of the doors opening, then there's we would identify there's going to be a problem with that lift in the future. So we could monitor that, the power draw, and then we'd build that into a predictive maintenance model, so we can start to predict when lifts are likely to break down and get them repaired before they went down. But this was a number one issue. Got a lot of disabled staff. Students, by all amounts, don't like walking up one flight of stairs, which is quite an unusual one. But this is what the number one complaint was. So not only that, and this is Imperial College, probably most universities that we are speaking to, we're speaking to about 10 at the moment, are having issues around space utilisation and well-being in the lecture theatres. Their audits are normally done once a year, and it's normally done by paper, whereas we can start to look at how we would do this dynamically and providing proper utilisation stats so they can optimise the learning environment for students. Wayfinding is another big thing as well. So they all tend to have apps, and we're looking to build, hopefully, some integration into the apps that we provide some of these services. Another service that we are providing is bot services, and the bot services framework from Azure, be able to communicate with students, staff, using a bot. So whether it's looking at where is there a free space in the library, can I book it? That's the type of stuff that we're looking at, so we can start to quiet places and things like that. So interesting stuff that's going on in that space. So considerations. As you can probably see, a lot of moving parts in an IoT solution. And a lot of opportunities, I feel, for businesses to start leveraging or even dipping the toe in the water with regards to looking at some initiatives that could be driven internally with IoT. So even if you reach out to other elements within the business and start looking at what business outcomes are likely to be driven. So if it's operating costs or looking to, like the medical asset tracking one, for instance, it was to improve the performance or productivity of clinicians and nurses with regards to medical assets, but also the theft, where the assets are. There's also reduction in lost equipment. It all has a financial impact. But if we start looking to other business entities within that within your establishments, or you can start to feel that is there any opportunity we can start to use technology to solve some of these problems using IoT, big data, and some app dev. Ensure that IoT is supported horizontally. So this Centre of Excellence we briefly spoke about is getting a team of people with a sponsor with the right touch points, so into the business leadership as well as into the different entities within so finance, HR, making sure that everybody has an input into that IoT Centre of Excellence, and if there's going to be a strategy, they can also build into part of that strategy as well. Ensure that security is actually done at the start, not done at the end. As most projects are, security tends to be done at the last part, and also costs the most money to do it if you do it at the end. So ensuring that security is built in at the start of that particular project, then everything after that will be built accordingly and will capture security end to end, which is obviously important. IoT is most certainly an ecosystem partnership play. It's absolutely key. We couldn't do a lot of the stuff that we're looking to for customers without the partnerships with the likes of Yanzi, Disruptive Tech, Arrow from a distribution perspective, Tech Data. So we pretty much can find every single requirement for a customer, whether it is existing or it needs to be built. So then partnerships are very key. When you're looking at building optimization, you start to build new stuff or build new buildings or you're doing refurbs, you don't need to think about building these particular sensors into the fabric of the particular buildings, or retrofit is fine. Because this technology is changing so quickly, is that you're likely to be ripping stuff off the walls and replacing it with a more up-to-date, more accurate sensor, or something that provides different types of data for you going forward. So retrofit is fine, and I think Microsoft a testament to that in Redmond. They had 65,000 people in the campus across there, and they decided that they want to build it into the fabric, and found that it just, after the 2-3 years it took to do it, they're ripping sensors out and obviously having to redecorate and things like that for the sensors coming off the walls and being taken out of walls and things like that. So retrofit is fine. Always start with an assessment. Assessment is probably that's what we found, is that you gain so much more information about what you're trying to do. Stuff that you didn't know about, stuff that you did know about, but there's some certain parameters you didn't. It's a very useful exercise also from a business perspective, understanding the outcomes more, and also engaging with different people within the business to ensure that we're capturing the right information. The assessment is probably been the most important factor that we've found, that moving this to P&D and doing it from a digital services perspective has been the best approach we've found since engaging on this journey probably 18 months ago. When you're looking at power, sensors, whether they are powered from a normal power supply, having sensors in certain places, we've been having to put power feeds in certain places, which is they're not always available. So when you are speccing stuff, that power becomes extremely important. But also where you've got mobility, so where sensors are moving around, is looking at battery life and looking at a sensor as the capability to run for that 5 to 15 years, because obviously the operational administration of change them batteries out or the power is going to be extremely difficult. And then evaluate your business with resources. Do they have the capability to run? Have they got data scientists? Have they got data engineers, business analysts? Most people will do, but these guys will need to tie this in from a digital perspective and ensuring that you're working to a common aim and a business outcome. You're going to have a lot of people need to be involved and making sure you're having the right resources. We know ourselves trying to attract the right type of resources and skill sets has been extremely difficult. So working through getting data scientists on board, having our data engineers, the cloud architects, we've got them all in place, but it's been very, very difficult to recruit and get the right people to come on board. So something to take into consideration if you're looking to do some of this stuff yourself, but either do that or partner with a company that can do it. So I think that brings us to the end. So all I can do is thank you everybody for their time. I know it was an hour and a half. I hope it's time worth spent with us talking through what we've been doing in IoT. And the next session, which is likely to be in the next couple of months, is probably going to be around digital twins, what we found, and more of a deep dive into that technology. So I'm sure you'd all like to join us on that particular webinar. So I think we're probably going to open up for.
Yeah, we've got any questions?
I've not got any questions, I don't think.
Okay.
Can't see any. So if I open up the audio now for you all. So are there any questions? I think, Gary, you're on INS.
We'll turn back on to restart.
Questions?
No.
Okay. Well, thank you for your time, and we'll look forward to speaking to you in the future.
Thanks very much, guys. Have a great day.
Thank you.